Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we start with kita Al-Fatihah. Alhamdulillah. Welcome to SFS2073, our fourth week and our third session, live session, okay, synchronous session. And inshallah today we'll jump into the new topics, which is determinant and matrices. We will cover this topic for 2 weeks. This week for determinants and next week inshallah for matrices. Okay, and also we have a task for this topic, which is tutorial, same like last week. So inshallah, actually everything ready in the goals, but I will make it available for you maybe tomorrow inshallah. Okay, okay, please check from the meeting chat, then you can get the attendance list there. Okay, and any question you can send through Q&A session, Q&A, and then I will try to answer anything. Okay. Again for last week, okay, for videos, okay, because we make online videos for you to study for the last week topics. I will create a quiz, simple quiz, just 1 or 2 questions. No mark given for that. It's just to collect your attendance. So it will show that do you understand the video or not. So I will create the link maybe this afternoon and will upload new goals. So I hope all of you can click that. Then it will catch as your attendance for last week. But I will not giving marks for that. Okay. So that will be just for attendance, for the sake of the attendance. Okay, and for this part of 7 weeks before mid-semester, we have 3 chapters. Okay, just recap what we we can check from the lesson plan, but we recap again. This is the 2nd chapter, and then another 2 weeks we have another chapter, which is infinite series. That will be long chapter. For infinite series will be unsynchronous, means that everything with videos you can check from the goals. Okay. After that, after mid-semester break, we have tests. Then we continue with the new chapter. Again. So right now we have only half of attendance. I believe that you have class before. I think this 30 or 35 we can start our live session. You have any question, you can ask from Q&A, and I believe everyone has submit from the last task. Okay. Okay. Next we begin for our new topic, which is determinants and matrices. So right now we discuss more on the determinants, and then next you will discuss on the matrices from the YouTube video. Okay, what is determinants? Determinants. Okay, this just line out for the what we learned today. Okay, determinants I believe that you have met before for matrices, and also for last chapter, which is vector. Okay, for this topic we have homogeneous linear equation, inhomogeneous, and then we have linear equation systems, which is linear independent equation, and as well as linear dependent equation. And we have also numerical evaluation. And last keyword will be Cramer's rule, which is main thing in the determinants and how to solve the determinants. Okay, so when we talk about homogeneous and inhomogeneous, we want to know what is a homogeneous equation. Okay, example homogeneous equation is 2x plus 3 3y equal to 0 and x plus y over 2 equal to 0. Example. So this we call as a homogeneous linear equation. Okay, and we can solve this and you can get the value of x and y. For inhomogeneous equation, we have an example plus 3y equal to maybe 7 and x plus y over 2 equal to 4. So this we call as a inhomogeneous. You can check video for homogeneous and inhomogeneous from YouTube. Okay, you can get a lot of videos there, and from there you can have a lot of questions there. Okay, you cannot get the attendance list. Okay, and maybe I need to send again. Okay, anything there? Can you see the attendance list? Okay. Okay, I try to make an announcement here. Okay. Also, you can check from the Q&A. Send you the link for attendance. Okay. 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 Next, linear equation system. Okay. And actually, what you dealing in the determinants is something we call as a linear algebra. Okay, I believe that algebra you have learned at math. Okay, at analytical addition mathematics. Okay, but for right now they have what we call as a linear algebra. Okay, this is linear algebra, but we cut it short and we learn simple one that really relate to the physics. Okay, because in mathematics they have a linear algebra subject and also for the computational. Okay. So we move to first topic, which is homogeneous linear equation. Okay. We are dealing with the homogeneous linear equation. Need to make it big. Okay. For homogeneous linear equation, okay, so look a bit clear. Okay, for homogeneous linear equation, I already explained what is homogeneous. Okay, so we can some history here. The concept from the Goldberg Wilhelm von Leibniz. Okay, to solve the linear equations. Okay, the concept of the determinants and the notation. Okay, so what is really the determinants? Okay, and actually you have already done it. Okay. The determinants when we are dealing with the cross product. Okay, so you can check from here. This what we call as a determinant and determinants. Okay, if you remember this. So the concept of how to do this is the same with what we have learned from vectors. Okay. So now, okay, just to recap, if you want to remember, okay. So how to solve this? Okay. Because this the vector of two linear algebra. Okay, so right now we are dealing with 3ijk. So now to solve this, okay, the vector a2 for this one I, okay, for a2 times b3, a2 b3 minus a3 times b2. So they have something like this. Okay, minus a3 b2. Next, j is minus because is the odd permutation. Because for here j, okay, so we cancel j here. The calculation from I to k. If you calculate from k to I, become positive. How? Okay, put I here. We have some method we learned in the school. Okay, a1 and b1. So for this one, the j will be positive And because the calculation we have here, A3 B1 minus A1 B3. But right now we are making J negative, so means that A1 B3 minus A3 B1. And the last one will be plus K, the vector K, okay, for vector K here, okay, this one the vector K. So we have here A1 times B2 minus A2 times B1. Okay, so here is the what we call as a cross product. Okay, that's the answer here is the determinants. It same goes to the 3 times 3. Okay, 3 times 3 something like here. This 3 times 3. Okay, 3 times 3, 3 times 3 matrix. Okay. So we go to the homogeneous linear equation. Okay. For homogeneous linear equation, using next. Okay. We have set of linear homogeneous algebraic equation. And the three unknowns is x1, x2, and x3. Okay, right now x1 is equal to, some books are using not just x1, x2, x3, but using x, y, and z. Okay, so they have three unknowns here. And this is really important when we calculate, because it's very difficult to get the answer for three unknowns value. So that's why we need to find how to solve this. Okay, they have same unknown value here, x1, x2, x3. Okay, and for a1, a2, a3, b1, b2, b3, c1, c2, c3 we call as a coefficient. Coefficients. Okay, this one is a, vector b, and vector c. Okay. For this value, okay, it's easier when x1, x2, and x3 equals 0. So definitely you can get the value 0 here if x1, x2, x3 is equal to 0. But that's not the solution that we need. Okay, it's not making it easier for us. So that's not the solution that we want to get from here. So we need to create a determinant before we can calculate. Okay. Here we are using the vector notation for x1. Okay, we know for x1, x2, x3, and then for vector a, which is a coefficient a1, a2, a3 here. For a1, a2, and a3, b, b1, b2, b3, and c, c1, c2, and c3. Okay. And then we know that for x dot a is equal to 0, x dot b equal to 0, and x dot c is equal to 0. So what's mean? If you remember, dot product, okay, example for dot product is equal to e, okay, example here, vector, magnitude a, magnitude b times cos theta. Okay, a and b is in any value, but right now cos theta. If the value equal to 0, means that cos theta is equal to 0. So when cos theta is equal to 0, again, it's a wave abbreviation. Okay, so we can open this graph. Okay, this is cos graph. Okay, because cos graph will start from number 1 here, and then half of this, which is 180 degrees, and the last one will be 360 degrees. Okay, cos theta equals 0 means the value is here. Okay, 90 degrees. Okay, so we know that the vector for x and a is 90 degrees, which is orthogonal. Orthogonal. Okay. So that would be the something useful that you can get from the information. And then how to solve this? Okay, so this how to create the determinants. Okay, from here you can see from a1, a2, a3. Okay, a1, a2, a3, b1, b2, b3, and c1, c2, c3. We can get this we call as determinant. Okay, And if the value of this determinant, okay, is not 0, means any value 1, 2, 3, or 4, okay, it means that the vector x is equal to 0. x1, x2, x3 equals 0. Okay, it's become ED1. If x1, x2, x3 is not 0, then the determinant will be 0. Okay, so that will be the case for this. And do you know how to solve this? I think I have shown you before. Okay. And this is what I told you, the geometrical interpretation. X is orthogonal to A, B, and C. Okay, orthogonal means that the 90 degrees. Okay, so means that for this one will be the vector A and vector B in the flat surface, and this will be the X. So it will be the 90 degrees. Okay. Then we can check how to solve this. Okay. Okay. So this is the easiest way, okay, to do, because the homogeneous, okay, the homogeneous for each line of equation, okay, means this equation 1, 2, and 3, okay, because all equal 0 means that A, B, C is just a ratio, okay, for x1 to x3. So we can make the calculation here. The ratio x1 over x3 is A2B3 minus A3B2. Okay, and for x3 is A1B2, A2B1. How you get this? Okay, you can check again this equation. Okay, sorry, from here, example A1, A2B1. Okay, here, okay, I can bring into here. Okay. Okay. So for this, so for A1, A2, A3, okay, example for x1, okay, is, okay, so this we will become the 2 times 2 determinants, okay, and then we need to remove the C1, C2, and C3, okay. So now we have here for x1 is A2 versus B3, A2 B3 minus A3 B2, okay. For x2, okay, for x2 is A1 B3 minus, because this one is something like AJK, okay, minus. So we have here A2 B3 minus A3 B1, okay, minus here, and then we have the x3, okay. For the x3 here, so we have A1 B2, A1 B2 minus A2 B1. We not calculate the C, since that everything is the same for ratio. This is easy to solve the 2 times 2. We assume that A1 B2 minus A2 B1 is not equal to 0, because if equal to 0, we will be the infinity. Okay, so this is a basic grammar rule for the 3 homogeneous linear equation. It's not solve anything. And we can see in another topic, another method later. Okay. And next will be the inhomogeneous. Okay, so we have done of the homogeneous vector, linear equation. So now we have the inhomogeneous. Okay, for inhomogeneous, to deal this inhomogeneous, maybe we take the 2 unknowns. Okay, 2 unknowns here. Okay, 2 unknowns. Okay, so we have 2 unknowns here, which is x1 and x2, x1 and x2. Okay, and it's not equal to 0 because it's equal to what we call here A3 and B3. Okay, so we have here the value for vector x is x1, x2, and -1. Okay, because if you arrange here, is become A1 x1 plus A2 x2 minus A3 equal to 0. So x3 is equal to -1. That's the idea. Okay. And how to solve this? We are using the Cramer rules. Okay. So here we decide the determinant. So determinant will be A1, A2, B1 and B2. So here A1, A2, B1 and B2. So to solve this, the determinant will be A1 times B2, A1 times B2 minus A2, B1. The cross will be A2, B1. Okay. So this the positive part and then this the negative part. Okay. So this will be the determinant. And how about the x1? Okay. For x1, this is something unique in the Cramer rules. Okay, something interesting. When we put the x1 here, okay, x1d, so means that we will put this value in the column number 1 here. So it become A3, B3, A2, B2. I will explain you later how to do this. Okay. An example here for x2, for the second row, we will replace the A2 and B2 and it become A3, B3. So from A3 here, change here. A3, B3 and B3. Okay. So this for the dx1 for x1. Okay. So here we have again A3 B2 minus A2 B3. Okay, plus minus. And again here for x2 is A1 B3 minus A3 B1. Okay. And to get the value for x1, example here, x1, the way you do it is because we have determinant here. Determinant is so we can put here A3, A2, B3, B2 over the determinants is A1, A2, B1, B2. And actually we already solved this solution. So it's become A3, B2. Okay, here A3, B2 minus A2, B3. This is from here. Okay. Over determinant is here, A1 B2 minus A2 B1. Okay, so for here also x2, okay, so means this one is over D. Okay, when over D, okay, cut it short, it become A1 B3, I took from here, okay, minus A3 B1 over the determinants. The determinants will be the A1 B2 minus A2 B1. Okay, so this will be the solution for x1. This is the solution for the x2. And the rules should be the determinant is not 0. Determinant is here. Okay, so the determinant should not be 0 because if 0, then automatically the x1 and x2 is infinity. Okay. I hope everyone understand. Okay. So this is a Cramer rules also for set of two inhomogeneous linear equations. Okay. So this one is a little bit simple. Okay. And actually some of the solution in the wave also using this method. Okay. And okay. Any question? Okay, to make it generalized, because in physics they make a lot of generalized because they can use for other rules. Okay, so example for this one, how to arrange determinant. Okay, actually sorry for this because we cannot make more than 3 versus 3 or 4. This one I can add. For the below part you cannot add, so it's become non-generalized. Okay, which is bigger lah. A1, A21, A31. Then it continue 41, 51. Okay, 61, everything. Okay, so until AN 1, which is 1, 2, 3 is number of rows. Okay, so 1 row 2. Okay, and the one for the second part here is column. Okay, so example here A1, row number 1, columns number 2. Row number 2, columns number 2. Row number 3, columns number 2. So it continues until to A and for the column number 2. So finally you can get here A for columns N and row N. Sometimes they change I and J, row is I and N is the columns. Okay, so using the Levi-Civita symbol, okay, so physics like to use this Levi-Civita. Make it bigger here. So by using the Levi-Civita symbol, you can make here E, I, J, K for the A, B, C vector. Okay. This for the generalized, okay, and the expansion will be different depend on the chapter or the problem. Okay. Okay, no questions so far. Hopefully everyone understand. Okay. So this one is an example for 3 versus 3. Okay, this is example for 3 versus 3 that we have discussed before. The determinant of 3 versus 3, or we call it using matrix. Okay? This one we call it as determinant. This is determinant, and the inside is the coefficient. Okay, the determinant of order 3 will expand into 3 factorial. 3 factorial. Okay, what is 3 factorial? If you remember, when we put example, 3 factorial is equal to 3 times 2 times 1, so is equal to 6. Okay, just a recap here. 6 means that it has a 6 equation or 6 parameters there. Okay, because example A22 times A33, okay, times A11. Okay, one terms, and then minus, okay, A11, A23, A32 will become term number 2. So total will be 6 parameter. Okay, so this the Levi-Civita. Okay, so this is the number of the Civita for the determinants for 3 times 3. Okay, next will be the linear equation system. Okay, so we have another two. Okay, linear equation and also the numerical evaluation. Okay, so the linear equation system, we can deal how to solve this. Okay, we have an example here. So again, we are dealing with something like general equation here. Okay, so we have equation number 1. Okay, so we can call it inhomogeneous if H1, H2 and H3, not all of them is equal to 0. If one of them more or everything, every H here is has a value, it's not the homogeneous anymore. Okay, and they have some interesting rule in determinants. Okay, the properties. Example here, this will be the determinant from the linear equation here. Okay, usually for dealing this, it has a x1, x2, x3, okay, and equal to h1, h2, h3. Okay, that's how we write it. Okay. Okay, I need to clean up a bit here. Okay. Okay, this one is x1, x2, x3. Okay, so that's actually this is not the determinant. Okay, that's what we call as a solution for the linear equation. Okay, but right now this is the determinant. Okay, it has several properties that interesting when we deal with the vectors. The determinants. Example here, when we put x1 and d. Example, we have vector a1, a2, a3, b1, b2, b3, and c1, c2, c3. If we times k, okay, so I want to ask you which one is correct. Okay, either become okay, this is the answer for A. Okay, A1, K, B1, K, C1, K, A2, B2, C2, A3, B3, C3. Okay, okay. This number one. Okay, number two is times K. Then what the answer we can get? A1K, B1, C1, A2K, A3K, B2, B3, C2, and C3. Okay, and this answer number two. And okay, and for C, okay, for C here. So for C, what will be the answer? Okay, sorry, for C, maybe you can get A1, B1, C1, A2K, B2K, and C2K, A3, B3, C3. Okay, D, you can get A1K, B1K, C1K, A2. Okay, so which one the answer? If we have the determinants A1, A2, A3, B1, B2, C1, C2, 3 times K, which answer is correct? A, B, C, D. Please answer in the chat. Okay. Okay, try answer. So which one is the correct? A, B, C, or D? Okay, ada some of your friends says the answer will be D. Okay. Others? What will be the answer? Okay. It is either A, B, C, D. Or maybe possibility 2, or maybe everything. Okay. So we have answer D, A. Okay. Many of you answer D. 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 Shafiq also answer D. We have many of you answer D. Okay, and then some of you. Okay, Aisha Nisa also answer D. We have some of you answer C. Okay, and okay, there are two of you that answer A and B. Okay, Amir also D. Okay, so we have two answer A and another one answer B, one answer C, other than that answer D. Okay, so the answer is, the answer is A and B. Okay, both are correct. C and D is not the solution for times the determinants. Okay, so example here. Okay, thank you for your response. So example here, x1 times determinant. Okay, this is the determinant that I cancelled up before. Okay, so the D times the x1. So we can make x1 here. Or x1 times 2. It doesn't affect the determinant. Okay. And some of the ways, okay, to do this, this how we can get from the Kramer rules. Okay. The Kramer rules that we have used before. Okay. So right now, some properties you can add A1 times the x1, okay, B1 times x1, C1 times x1, and then we can add here for plus A2 x2 plus A3 x3, okay, means that the x2, okay, we add the vector x2 times the row number 2, x2 times the row number 2, 2 and 3, okay. So this is equal to H1, this one is H2 and H3. Okay, so finally for x1d, okay, x1d is equal to H1, H2, H3, A2, B2, C2, A3, BT, C3. That we have discussed before, why it replaced the one of the column. Okay, so getting a value of x1 means that x1 over equal to 1 over d, H1, H2, H3, A2, B2, C2, A3, B3, C3. Means that D mean if you cancel here, you can make here D is below. Okay. Okay. So D means that the first determinant, which is here, A1, A2, A3. So the solution of determinant here and then the x1 here. So for x2 also here and x3 is also here. Okay. What happened if the determinant equal to 0? What happened if H1, H2 and H3 equal to 0? Okay. So if determinant equal to 0, automatically the x1, x2, x3 is infinity. So we cannot use this as a solution. But what happened if H1, H2 and H3 is equal to 0? What will be the value for x1, x2 and x3? Okay. So any answer of you? So what will be the value for x1, x2, x3 if H1, H2 and H3 is equal to 0? Okay, so any answer? If H1, H2 and H3 all three equal to 0, what will be the value for x1, x2 and x3? So as physicists, you can make a prediction. Okay. So I'm waiting for your answer. What happened to x1, x2 and x3 if H1, H2, H3 is equal to 0? And the determinant is not 0. Means the determinant have the value. Any answer? Okay, so if H1, H2, H3 equal to 0, what will be the value for x1, x2 and x3? Yes, the value is still the same. Okay, that's the hint. X1, the value for x1 is equal to x2 and equal to x3 because of the H1, H2, H3 equal to 0. So what will be the prediction? Okay. So I think it's easier to predict compared to the first time we want to predict, is it Donald Trump or John Biden winning? Okay. So right now we know the decision. Okay. I don't know. Okay. Anyone can predict this? Infinity. Okay. Some of you say infinity. For infinity, if the determinants equal 0, means the A1, A2, A1, A2, A3 is equal to 0. Okay. The value is 0. But right now, the determinant, okay. But H1, H2 and H3 is equal to 0. What will be the answer? The infinity if the determinants equal to 0 means that the coefficient, okay, the value for coefficient is equal to 0. Thank you. Okay, no problem. Thank you for your comment. Thank you. So, any idea? It has some value. Yes, it has the same value. But you can make a prediction. Okay. 0. Okay. Correct. Okay. Oh, it doesn't put your name here. Yes. The answer is 0. Why? Okay. So, example, we took the solution for the x1 over d. Okay. For x1 here. Okay. So we know that d have a certain value. Okay. Makes sense. Okay. Right now, what happens if h1, h2, and h3 equal to 0? So we have here 0, 0. I think I don't have enough space here. Why not make something here? Okay. So example h1, h2, a3 is equal to 0, 0, 0, 0. Then we have here a2, b2 and c2, a3, b3 and c3. And I'm using pencil and not very satisfied. Okay, I change to pen. Okay, okay. So now we have 0, b2, c3. Okay, how to calculate this? Imagine that this is ijk, ijk. Okay, how you solve this? Okay, the first column here. Okay, so we start from first here 0 times. Okay, because of the 0 here, so means that we block. Okay, this, so we only solve here. So for this is B2 times C3 minus B3 times C2. Again, positive, negative. Next, the J. Okay, the J part here. Okay, minus 0. Minus A2. Minus 0. Okay, minus A2 because the A2 here. So right now it's okay. Can in here. Okay, right now for A2 is here and here. So we put A2 here and the solution is 0 times C3, 0 times C3 minus B3 times 0. Okay, 0 to C3 minus B3 to 0. Okay, so again here. Okay, so next will be plus, ini sepatutnya kat bawah ni, okay, plus A3. Oh, A3. Okay, so now we can okay, it's not okay here. So okay, A3. Okay, so for A3 something like this. Okay, so the solution is inside here. 0 times C2 minus B2 times 0. So what will be happen? This 0 times any value here, even 1 million, the answer will be 0. Right now, 0 times C3 is 0, B3 times 0 also 0. Means that 0 minus 0 is, this is 0. So 0 times A2, the answer will be 0. A3 ini also 0 minus 0, so the answer inside is 0. 0 times A3 is 0. So the answer is 0. The same goes if we put the H1, H2 and H3, okay, in the middle or the last one of the column. Which assuming that D has a value. Okay, so clear? I think everyone clear for this? Okay, so inshallah we can complete our syllabus today for this part. Okay. And okay, this what we call as a Kramer rules. Okay. They have one solution that we can use this in the wave and vibration. Okay. But sometimes skip it because some of you will confuse with other method which is simpler. Okay. So right now, when we deal about the linear equation, okay, linear equation system for this one, okay. Sorry. Okay, this. When we deal about the linear equation system, okay, we have two linear independent equation and linear dependent. Okay, independent means it depends something. Independent is not depend to anything, but dependent equation they have a something we call dependent equation. If independent equation, if D is not equal to 0, which is D is determinant, the basic one, the determinant. Okay, I will show you here. The determinant. The first one. Okay, determinant has a value. If the determinant value means that x1 is not infinity, correct? If D is not equal to 0, okay, and if H1, H2, H3 is equal to 0, that's what we deal, okay? The xi means that I is 1, 2, 3 is equal to 0. All the x is equal to 0. And this is what we call as a homogeneous. Okay. But if this D is not equal to 0 and H1, H2, H3 also not equal to 0. Okay. So means that D has a value, H1, H2, H3 also the value, means that we have a value for x1, for x2 and also the x3. All three we have the value. We have a unique and definite value. Okay. So if we have H1, H2, H3 is not homogeneous anymore, it becomes inhomogeneous. Okay. And x1, x2, x3 or can continue until x10 or 100. Okay. Have a value. That we call as a linear independent equation. Okay. What happened to linear dependent equation? Okay, linear dependent equation is D is equal to 0. Okay, means that the determinant of equation is 0. Okay, D. So there's a different way to deal it. Okay, how? Okay, we can check this. Okay, linear dependent equation also has a homogeneous and inhomogeneous. Okay, when we talk about homogeneous means that H1, H2, H3 equal to 0. If not, then it's become inhomogeneous if either one is not equal to 0. So that will be the prediction. Okay, any question? Clear, alhamdulillah. Thank you very much. Okay. Oh. Sorry, where is your share? Okay. Okay, take 1 minute rest. Okay, saya pun nak bernafas kat tak 1 minit. Sikit lagi insyaAllah, very near to the end. Okay, right now, we continue. Okay, so right now we try to solve some problem here. We have x1, x2, x3, x1, 3x2, 5x3, and x1, 2x2, and 3x3. So means that a1 is 1, a2 is 1, a3 also 1. Okay, this one is b1 is 1, b2 is 3, and b3 is 5. Okay, so we can make this determinant value or saying it. Okay. Okay, and a1 is 1, b1 also 1, c1 is 1, a2 is 1, 3 and 2, the last one will be 1, 5 and 3. Okay. And then how to solve this? So it's easy, okay? When we deal about the linear dependent homogeneous equation, you can check there again. Linear dependent means that D equal to 0. So we must prove that this D is equal to 0. Okay. So we start with number 1, okay, here for row 1 and column 1. So when we deal about row 1 and column 1, okay, we put number 1 here in front, and then 3 times 3, 3 times 3, okay, minus 5 times 2, 5 times 2, okay, minus the second row, okay, change to the second row will be this. Also number 1, but 1 times 3 minus 5 times 1, 5 times 1. And the last one, okay, again it's not enough space, okay. The last one will be row number 1 and column number 3. So we have here plus 1 also. 1 times 2, 1 times 2 minus 3 minus 3 times 1. Okay, so what we have here, okay, 3 times 3 is 9, 5 times 2 is 10, 1 times 3 is 3, 5 times 1 is 5, 1 times 2 is 2, 3 times 2 is 1 is 3. Okay, so we have here 9 minus 10 is minus 1, minus 1, 1, minus 1. And then we have here 3 minus 5 is, minus 2, minus 2 times minus 1 is plus 2. And then we have here 2 minus 3 is minus 1, minus 1 times plus 2 is minus 1. So we have here minus 1 is minus 2. So the value is 2 minus 2 equal to 0. Okay, so confirm this is the dependent. Okay, so the dependent means that the value is equal to 0, the determinant. The determinant D is equal to 0. Okay, and this homogeneous because this is equal to 0. Okay, this is a keyword, homogeneous is equal to 0. And for line dependent, linear dependent is equal to 0. And then how to solve this? Okay, and we come back to this equation. Okay, I need to have some space here. Okay, so we took this first equation here. Okay, I need to copy everything again. Okay, second row equation and the third row equation. Oh, banyak. Yep. The third row is okay. Okay, so we have here first row, second row, and third row. And how to do this is we need to remove the first row. Remove the x1. How to do this is we took the first and second row. Okay, first and second row. How the second row minus first row. So how to do this? Okay, this is the second row. Okay, the first row minus the first row here, x1, x2, x3. Okay, so we minus x1 minus x1 is equal to 0. 3x2 minus x2 is equal to 2x2. 5x3 minus x3 becomes 4x3 equal to 0. So from here, we know that 4x3. Okay, we know that 2x. Okay, 2x2 is equal, 2 equal to minus 4x3. Okay, we can cancel out this. We have here x2 is equal to minus 2x3. Okay, this one solution. Another one is we cleaning the x2, okay, using the second row and the first row also, okay. And for this one, okay, using the second row and the first row also. First row we times 3 minus the second row. Okay, so first row times 3 means that we have here 3x1 plus 3x2 plus 3x3 equal to 0. Minus the x2 is x1 plus 3x2 plus 5x3 equal to 0. Okay, so when we minus here, okay, 3x1 minus x1 we get 2x1, 3x2 minus 3x2 is equal to 0, and 3 minus 5 we can get here minus 2x3 equal to 0. We rearrange, we have here 2x1 equal to 2x3. Again, we have here x1 is equal to x3 because the 2 is cancelled. So now we have here the value that we know that x1 is equal to x3, and the x2 value is equal to minus 2x3. Okay, and when we make put a certain value, example, if x1 is equal to 1, so means that x3 is equal to 1. Okay, automatically 1. So what happened to x2? X2 become minus 2. So we have here x1, x2, x3 is equal to 1 minus 2 and 1. Okay, so that will be the solution for the dependence. Okay, so one of your friends asked why we need to times 3 for the first row. Okay, when we times 3 the first row, because we want to make sure that x2 is same. Okay, the parameter for the x2 is same. Okay, so what happened is here, because x1, x2 and x3, x1, x2 and x3, okay guys, everyone confused about this. Okay, right now, okay, so when we have here x1, x2, x3 and x1 to x2 is 5x3, we want to clear up the x2. Okay, to cancel out the x2 means that we times everything into 3. So when we times into 3, we have here 3x1, 3x2 and 3x3, and then we can minus the second row x1, 3x2 and 5x3. We can clear up the x2 because right now for this answer we don't have the x2. So we have the value for x1 and x3. Okay, that's the reason why we make this decision. Okay, or maybe you want to cancel out the x3 example. You can times the x1 times 5, 5, 5, 5. Okay, so when we times 5, 5 minus 5, okay, x3 cancel. Right now 5 minus 3 can get 2x2, and then 5 minus 1 it can 4x1. So we have here x1 is equal to minus 2x2. Okay, it's the same thing with this. Okay, okay, so that's the reason. The reason because the best part, because this doesn't affect the right side right now, because both this is 0. If it has a value, also same, because this will minus this. The reason because we want to cancel out the x2 here. That's why we times the 3. Okay, so that will be the trick to do this. Okay. Okay, clear? Why we must times 3? Okay, when we times the 3 multiply to 3, okay, so automatically when we minus row 1 and row 2, we can cancel out the x2. Okay, so for the second way, because we want to remove the x2, we want to make sure what the value for x1 and x3. So that's why we came the conclusion that x1 is equal to x3. 3. Okay? Okay, clear? Clear? Okay, okay. Thank you. Okay. Alhamdulillah. Clear? Okay. Clear, we can go to the next subtopic. Okay, so just 12 o'clock. And the last one is Gauss elimination. Okay. It's part of the, we call as a numerical evaluation. Okay. So please bear with me. The calculation will be long, even though the slide is very simple. Okay. In mathematics, Gauss is very popular. Okay, so just multiply anything to vanish the x2. Yes. Actually, because we already know that x1 is equal to x3, we can predict. That's why we can see that we times 3 so that we can remove the x2. Okay. Okay. Right now we are using the example here, okay, because we want to deal with the Gauss elimination, okay, penyingkiran. It's not just spot have the elimination, okay. So Gauss also using the elimination. The best part is because the Gauss elimination is not very, what we call as, not elegant. Oh, yeah. Use the elegance, okay, not elegance, but then because it's very because it's tak cantik lah, it's not look very nice, but it's very important, especially when we using the coding to solve this problem. Okay, so right now we have the Gauss elimination, and for here the first equation here is, okay, right now they're using x, y, z. Okay, it's easier to use x, y, z. Okay, 3x, 2y plus z equal to 11. This one is 2x plus 3y plus z equal to 13. And the third one will be x plus y plus 4z equal to 12. 12, sorry. Okay. And this method, it will try to remove part by part, okay, sorry, part by part, okay, one question to one question, the first x and then y and z. Okay, first individual each row to make x, the coefficient for x is 1, means that 1x, tak adalah no 3x, 2x, 5x, 10x, we have 1x only. So what to do is we divide everything for first equation into 3. So means that x over 3x over 3 it become x. Okay, plus, okay, 2y over 3, so means that 2 over 3. Okay, I make everything here clear. Okay, plus z also over 3. So is equal to 11 also over 3. So all on in this equation divide by 3. So what happen here? X can cancel here. We have 2 over 3y. We have 1 over 3z. We have 11 over 3. So the first equation will be x plus 2 over 3y plus 1 over 3z. Someone will confuse here. Equal to 11 over 3. Okay. The next one will be row number 2. Okay. We want to remove because you have 2x plus 3y plus z equal to 13. We want to remove 2 here. So we divide by 2, divide by 2, divide by 2, and divide by 2. So 2 divided by 2, we have here x. So what we have here is the second row, x, 3 over 2y, plus 1 over 2, z equal to 13 over 2. The last one, okay, doesn't need to change anything because everything, the x is equal to, the coefficient for x, 1. Okay, so we have here x plus y plus 4z equal to 12. Okay, that will be the first step. Okay, clear? Clear? Okay, second step, we will start the elimination. We will start the elimination. How? Equation row 2 and row 3 minus row 1. Okay. So now, okay, this is the first stage. Okay. So going to second stage. Okay, going to second stage. Right now, this is row number 1, row number 1, row number 2, and row number 3. So right now, row number 2 minus 1, row number 3 also minus 1. What happened? Okay. So right now, row number 2 minus 1. Okay, so row number 1 is stay. Okay, x plus 2 over 3y plus 1 over 3 z equal to 11 over 3. So right now, row number 2 minus row number 1. So when row number 2 minus row number 1, okay, we can change the color here. Row number 2 minus row number 1. Okay, row number 2 is here. Hmm. 13 over, okay, 13. 13 over 2. So minus the row number 1, x plus 3, 2 over 3, y, 1 over 3 equal to 11 over 3. Okay, so right now is 2 plus 1, okay, row number 2 minus row number 1, x minus s equal to 0. And then for y, we have here 3 over 2 minus 2 over 3 plus z, we have here 1 over 2 minus 1 over 3. The last one will be 13 over 2 minus 11 over 3. Okay, x cancel everything. The new second row, okay, we begin here. Okay, so right now 3 minus 2, okay, samakan pembawah. Okay, that will be the way we call it, samakan pembawah. Okay, so 3 times 2 is 6, 3 times 3 9, 2 times 2 4. So we have here is below 6, we have 9 minus 4, which is 5 over 6. So we have here 5 over 6 y, and then for z also same, 3 times 2 is 6, 3 minus 2. So we have here 1 over 6. So we have here plus 1 over 6 z equal to, okay, 3 times 2 6, 6, 3 times 3 39 minus 22. 17, okay, 17 over 6. So we have here 17 over 6. So here a new line for x, row number 2. So x equal to 0, we have here 5 over 6 y plus 1 over 6 z equal to 17 over 6. So next, what about row number 3? So row number 3 is minus row number 1, okay, the same way. Maybe I need to clean up here. Okay, it's like using the real madam. Okay, whiteboard eraser. So right now, row number 3 minus row number 1. So row number 3 is x plus y plus 4z equal to 12 minus row number 1 x, 2 over 3y, 1 over 3z equal to 11, 3. X is equal to 0. y minus 2 over 3y means that y 1y is equal to 3 over 3. So it become 1 over 3y, and then we have 4 minus 1 over 3z. 4 minus 1 over 3 is equal to 11 over 3, 11 over 3, because 4 times 3, 3 over 3, so we have here 12 over 3, 12 over 3. So 12 over 3 minus 1 over 3, so we have here 11 over 3. Okay, z, so equal to times 3, 36, 36 over 3 minus 11, so we have here 25, 25 over 3. Okay, so now the third row we have new equation here. Without x, we have here 1 over 3y plus 11 over 3z equal to 25, 3. So we complete the elimination of x1. X1, x. Okay, sorry. So we complete the elimination of x. And next, number 3, we try to eliminate the y. Okay, we try to eliminate y. So right now we are dealing only with these two. Okay, only these two. We're dealing with this. Okay, so when we try to eliminate y, so because we have 5 over 6, we make sure we want to make y is equal become 1y only. Okay, so what we can do here, because of the, okay, right now the equation for second row is the second row is 5, 6y plus 1 over 6z equal to 17 over 6. Okay, to make it clear, okay, clear y, okay, so we times 6, everything we times 6. Okay, and then we divide by 5. So we divide by 5, we divide by 5. So what will be happen here? 6 will be cancelled, 6 will be cancelled, and 6 will be cancelled. This one 5 can cancel. Okay, so the new for second row here we have, okay, the first row same, the second row will be y plus, right now 6 cancel, we have 1 over 5z plus 7, equal to 17 over 5. Okay, next will be the third row. Same, okay, 1 over 3y plus 11 over 3z equal to 25 over 3. We want to clear the 1 over 3. The easy way will be times 3, everything times 3. So the y will be cancel, cancel 3, the 3 will be cancelled. So the new equation for the second row will be y plus, cancel 3 and 3, so we have here 11, z equal to 25. So we leave out the equation number 1 for this moment. Okay, because we want to clear up the row number 2 and row number 3. So the row number 1 is the same, x plus 2 over 3y plus 1 over 3z equal to 11 over 3. Okay. So now we cancel out y by, we eliminate y by minus these two. Okay. So third row minus the second row, what happened is, okay, third row minus again second row. Okay, so y minus y. Okay, so can have here y, if 1 minus 1 is equal to 0 plus, right now is z 11 minus 1 over 5 times Z equal to 25 minus 17 over 17 over 5. Okay, so the solution will be y is equal to 0 automatically because 1 over 1. Okay, so right now is 11 minus 1 over 5, so it becomes 54 over 5 z, so equal to 108 over 5. Okay, and then we have here, you can get the value of z. So we have here z is equal to 108 over 5 times 5 bawa ke atas. So we have 54 bring here over 54. Okay, and we can cancel out 5 and 5. 108 over 54 is 2. Okay, so now we get the answer. Z is equal to 2. Okay, and to get the value of y, okay, so we have value z. Why not we use this term? Okay, so we have y is equal equal to 25 minus 11, bring 11 here, 11z, z is 2, 22. So now 25 minus 22 is equal to 3. So we have here y is equal to 3. The last one will be x. Okay, x, you can put the value inside any of y and z, and finally you can get x is equal to 1. So now we have here x equal to 1, y equal to 3, and z equal to 2. That's what we call as a Gauss elimination using the numerical evaluation. Okay, so any question? Okay, we use R3 minus R1. Okay, ada question how if we use R3 minus R2, is that there is a rule we need to use R3 minus R1? Okay. Yeah. I think this one for step number 2, I think. Okay. For this step number 2, yes, we must minus the R1. Okay, because we want to remove X. But after that, we can keep the row number 1 at the bay, and we just minus row number 2 and row number 3 because we want just to remove the Y. For X, yes. Okay. Okay. And at step 3, why don't we eliminate Y from first row as well? Okay. We doesn't need to eliminate the row number 1 because we want to know the value of our intention is we want to get the value. Okay. So right now, after we eliminate, because right now the row number 2 and row number 3 doesn't have X. If we minus, example, minus row number 2 with row number 1, so the X will be there. Okay. Dia akan jadi negative X ataupun something like that lah. So right now we doesn't want X yet. We want to reduce the parameter, unknown parameter. Right now we have left Y and Z. When we remove Y and Z, okay, Y and Z here. So when we remove R3 minus row number 3 in row number 2 equation, so definitely the Y will cancel out. So it left out only Z. So the value for Z, then we can get the value after that. Okay, so the attention now is to reduce the parameter. So after this stage, we doesn't need to include the row number 1 anymore, because if we minus row number 1, number 2, everything, finally we doesn't have the solution. That's what. The only thing we want is to reduce the parameter so that we can get the solution. Okay, but for the first, yes, we need to minus the row number 1. Okay, some of your friends say, why not you minus to row number 2? If we want to minus to row number 2, everything minus row number 2. Okay, example for this one, okay, we make the row number 2 is the base. Okay, so means that R3 minus R2, R1 also minus R2, and then we left out the R2 after this. Okay, so we decide something like that. Okay. Okay. So I think you can answer your question. At step 3, why don't we eliminate y from first row as well? Because if we eliminate y from the first row, the x will live there. Klik dah macam tu kan. X will live, okay. So x akan tertinggal dalam row nombor 1 tu. Sebab kita tak nak, kita nak kurangkan supaya tinggal satu je parameter untuk selesaikan. So if we include for the third stage the row number 1, okay, sebab row number 1 tu x tu ada lagi. Kita tak nak x lah, nak tinggalkan x lah. Okay. And then kita pun tak nak tanya y dah, kita nak cari z je. Okay, so that's a big question. So if we include the step number 3 dengan row number 1, x tu ada lagi, kita tak nak x. Okay. And for yang another one tadi yang kenapa we use row number 3 minus row number 1, if we use row number 3 minus 2, okay. So the answer, if we use row 3 minus row 2, the first one, the first step, okay, row 1 also minus row 2, row 2 become the base. Okay, clear? So this from the textbook that I asked you to read, Afghan, okay. So I'm going to simplify, hopefully you can understand. Actually they have a few things that I think is too complicated, you can read from the textbook, okay. They have some properties also, they have Laplacian development by minors, okay. I think you can read from the textbook, Laplacian, okay, it's still important. And then the properties of the determinant. Understood? Okay, thank you very much. Alhamdulillah. So do you have any question? Okay, again, attendance, please fill up the attendance first. And then for the last week, okay, I'll make some quiz again, because not everyone, I'll make some simple quiz, not for mark, just for the sake for the attendance. Okay, clear. So alhamdulillah, and then I will upload the tutorial later by tomorrow. If not today, boleh upload lah, insyaAllah. If you have any question, you can send the WhatsApp also, okay. And I love when you send WhatsApp about asking about tutorial. Even though I'm not giving you answer, okay, because it's part of the mark. But I hope I give you some how to do this, okay. And congratulations for those who complete all the tutorial and submit. And hopefully you can maintain, and hopefully no problem after this, insyaAllah. Okay, so thank you very much. Sorry if you any disturbance, okay. Hari ni macam-macam, ada yang menangis, ada yang kucing lalu tadi kejap, nasib baik video tak ada. Okay, so video insyaAllah will upload later in the YouTube, and then I will put link in the goals, okay, for your reference. Notes also I forgot to upload. I'll try to upload this content notes, okay. So to make you have the ideas on the topic that we discussed today, insyaAllah. Kalau saya terlupa, ingatkan balik, sepatutnya saya letak awal, tapi semalam goes down kan. Okay. So alhamdulillah, thank you very much for everyone. Thank you for your times, okay. And okay, nearly 12:30. I think it's enough for today, and we meet again after mid semester. Okay, after this doesn't have the synchronous, unsynchronous only. Okay, so thank you. Okay, you're welcome. Thank you everyone. So assalamualaikum warahmatullahi wabarakatuh. Okay, Roger and out. Okay, kita dah keluar sekarang. Bye.